So we have been working on plots, okay? Before we even start plotting, what it is that you need to have first? Data. Without data, you can't plot anything. And that data should be in specific format, right? So a lot of times we're coming up with data that is really simple to compute, like cosine function, sine function, and the like, and combinations, okay? So we're doing relatively simple data. In reality, data is whatever matters to you. So you're going to be working or an intern somewhere, and there will be some data coming from somewhere that you need to present as a plot. Plots are always easier to comprehend than tables are. The moment you have in your table more than 6 values or 6 by 6, good luck a human comprehending it properly, right? So when you plot, we can see relative distances, relative sizes, way more easier. It's also way easier to figure out what is accumulation of points. And in petroleum engineering, we always have a lot of points. So if you think about a well log, right, we would like to see accumulation of porosities and permeabilities in a reservoir, and not just accumulation, figure out if there is some sort of a relationship between the two. And also we would like to see how things change spatially. Yeah? And for all of those things, we have to plot. So there are certain mechanics of how do I produce a plot, but having data is the first. So here's this example. I don't think I typed in this example. Okay. This is just how to juxtapose 2 different plots in the same figure. So there's figure, but that figure could have multiple plots within. Each plot has a separate set of axes, and that's what computer needs to know. So that's why we go into kind of defining little details, because computer has to figure out where to put your data. First plot, second plot, third plot, fourth plot, right? And what are the axes? So each of those subplots has everything that a single plot would have. And again, it depends on you what it is that you want to plot, what type of legend do you want to put there, do you want to throw in a title or not, like all of those things are details. So let's actually just figure out how would I actually split any plot. So here is my, I'm going to work from my 2.4 plots. This is what I also posted for you on Canvas if you want to. So we had a sine. So even if I wanted to, we had this plot where I plotted sine and cosine together. Okay? So they're obviously off by 90 degrees phase. So basically I had my sine data that was defined before that. So I have to give myself points to work with and compute sine of them. So that's my data. In the simplest versions of them all, I just plot that data. Okay? And I say just plt.plot xy. I have to import module matplotlib pyplot. This one is actually extra here. I can work without having it because I'm actually not using any other function other than this pyplot plot. So then if I wanted to put 2 sets of data, like here, okay, I can also compute cosine and I can just plot them together. So the basic function is plt.plot xy, plt.plot x and y2. Everything else is dressing it up. So here I wanted to control what type of markers do I use for every point. So I wanted to red circles and blue pluses. And then I can get that. If I want also a legend, I have to label each curve separately. And then I can call plt legend. And that's going to produce this thing. But again, key point here is just plt.plot. And there are certain defaults that might just well work. Okay, so you don't have to modify all of these details. The rest is just dressing it up. Cool. Now if I wanted to, I'm going to keep talking about font sizes. Now if I wanted to do separate plots, okay, then I would create my 2 types of data. In this particular case, the data I have is, so x1 is my set of points where I'm creating my y values, and it's cosine of, so my x is going between 0 and 5, and I'm letting it pick a default number of points in between. And then it's like 2 times pi times x times exponential function of minus x. And that's going to damp my signal. It's just mathematical damping. And the second is just my regular cosine. And I'm just spreading, I'm using 0 to 2, and I'm multiplying by pi right here. So either way you want to create the cosine function, it doesn't matter. And then what I have to tell MATLAB, has everybody created the data? It's Friday, I'm tapped out. So basically, this is my data. Now I want to plot this one on one plot, this one on the second plot that are one above each other. Now I have two sets of different axes in one plot, so I have to have a way to control that. And what we're doing is we're saying, okay, let Python know that there will be subplots. So there will be two plots and one sub in my arrangement, 1, 1, just thinking like a matrix. In the first row, first column, put this plot, and then whatever it is that I want to plot. So at the simplest, I would just put plt.plot of x1, y1, right? So if you want to put title or not, it doesn't matter. I'll just comment now title and label. And then the second plot, I'm going to say, hey, this is out of the two plots, this is plot 1, 2, right? And then plt.plot x2, y2, and I just want slightly different type of, so this is going to be dot dash type of plot. And sometimes when I have multiple plots, or I'm kind of, it should work without this PLT show, but sometimes certain information gets stuck. So this is just refreshing the figure. So if I execute this, then it doesn't execute first time, but it does second time. I get two plots in one. So again, two sets of axes. If I didn't do subplot, okay, if I didn't do subplot, so I just comment this for a moment just to see what would happen, then I'm gonna get something like this. This is how they would look like together on the same plot. Remember that one of them went from 0 to 2 pi, and the other one went from 0 to 2, and the other one went from 0 to pi. That's just the way data was. Okay? So if I want to separate the two, then I put a subplot. Okay? And then if I want to dress it up now, so my basic plotting is done. Did everybody catch what happened if I comment subplot? They just go on to the same plot. Whether that makes sense or not, doesn't matter. So then I could put a title, subplots. That's not very informative, but oh well. Maybe I can put something like signals. Plotting signals. And the top one has that damping in there, so I'm just going to call it damped. And the bottom one is undamped. And I'm going to put, since they're like right below each other on both of them, I'm just going to put one of the labels, not both of them. So when I execute that, then I have label time below both. And this one is undamped and this one is damped. Strictly speaking, if you were my graduate student and brought me this data, I'd be like, what are you doing? Have the same axes for two things that you want to compare. Okay? So then I would plot this one either larger or just look at it from 0 to 2 in order to compare both together. That's just a nerdy detail here. But here it doesn't matter, we're just learning the mechanics of how to create two plots.
How do you change the range of like the...
You could do axis limits, axis. So I could say PLT axis. And then I say 0, 2, and what was it? -1 and 1. I could also enforce -1 and 1 on both. It's either axis or axes. There we go. Okay. So everything that you can think of, like just like this, how to control it, what you can do. So you can definitely search for how to do it. All right. Now, who can tell me how can I change color? Let's say that I like red color better. Where would I specify red color for top plot, for instance? What is the code for red? R. So I can actually just put it in. That works. Yes? So these little descriptors of my lines and colors and all that, I can just pile up. I have no clue if you made a mistake of putting both red and blue, which one would take. Oh, I would have an error. It doesn't like two colors. It doesn't make it purple, no. Now this is, so R, K is black, M is magenta, which is purplish. Not quite sure what is orange. Is O orange? I'm going to test it right now. I had it on my slides. I don't think that there is a shortcut for orange. No. So I'm going to have an assignment for somebody who feels like searching online to figure out how to do orange. The key there is that all of the colors, they have red, green, and blue hue in there. So they're a mix of red, green, and blue. And color photos or anything are actually, so this colored screen that you see, this screen is a matrix of numbers. And depending on your resolution of the screen, this would be like 1200 points by 700 or 800 points. Okay? I think it's 1200 by 800, though on projector it might be a little less. Okay? So it's just like a matrix of numbers. Okay? And when I see colors, I actually have three matrices. One of them is red, one of them is blue, one of them is green, and they're mixed together. So I have different numbers for each spot. Each spot is described by three numbers, red, green, and blue. And they mix together. When all those red, green, blue channels are the same value, then I have gray, or scales of gray. Okay? So basically, for UT orange, there is a specific mix of red, green, and blue that gives us UT orange. Right? And if I really wanted that orange plot, I would go, UT website actually has the specification for red, green, blue for UT orange or red orange. Okay? So that you can find out. And then you have to find out with Python, okay, if I just want any color that I mix the way I want to mix, how would I specify that with three numbers? And there is a way to do that. Right now, from the top of my head, I don't know how, but I know that there's a way to do that. So if you want to search and you want to plot your plots burnt orange, you can, okay? So anything that you can, my point here that I'm just exemplifying, since it's Orange Friday or something today, Longhorn Friday. On Friday, faculty and staff are supposed to hear orange, if we actually listen. This Friday I did, so I'm proud of myself. Anyways, My point is that anything that you can think of how to modify your plot, it can be done. Okay? You're the one in charge, but the very basic mechanics of plotting is just plot. Give me the data, plot X and Y. That's for the data that comes as 2D. One more specific plot that I'd like you to try out because it's useful, okay, is this one. Okay? So when I have a bunch of numbers and I just want to look at the distribution of their relative frequency, how often they show up in my pile of numbers, that's where histogram is useful. So I'm going to actually create myself simply 10,000 points randomly. And this is going to be, they're going to be distributed as a normal distribution around my average 100, which is mu, and plus minus sigma. This gives me a normal distribution of numbers. Most of the random things are distributed normally. So this is just fixing that seed. If you want to always have reproducibility, you can omit this line and then you're going to get slightly different distribution every time. So this is, you can omit this. So this is just creating my data, okay? 10,000 numbers that are normally distributed around 100. 100 is my mu.
I have a question.
Yes.
How do you know what number to put with the NP.random seed?
Any. It's really any, but then it's gonna start with this seed as an input, right? And then this is likely somebody's birthday. Okay? Somebody was born in 68 on the 1st of August. I'm guessing. That's a very good guess. Okay. So this way, the seed will be the same every time I execute this. If not, these numbers will slightly change, and I'm going to have ever so slightly different distribution. Okay. So you will see when we plot, and you can remove it and see that every time. So random number, you can actually kind of, it's just going to draw a random number. And if you're looking for like rand function, it goes between 0 and 1. It could be any number between 0 and 1. And if you have only 1, that could be 0.2, 0.78, 0. Anything. If you want to fix that, you always execute the same when you're plotting something. So if you want to be control, then you fix the seed. So this way, this will probably pretty much execute the same way for everyone. Otherwise, it will not. Otherwise, we will have as many, different, slightly different versions that will statistically be the same. Beauty of statistics, you're going to get more of it in geostatistics. That's coming up. So then if I want to just plot the histogram, I have a function that does specifically that. I tell it how many bins, but even if I don't, I can just do plot hist of x and the rest is just figured out for me. But I'm specifying a little more. I want to normalize this histogram, so I say true. I want to give it color green and a little bit of transparency to my plot. So this is just to show you a little bit of what can be done. I'm not going to be testing you on these things here. Okay? It's just to give you something to play with if you need these plots later. And then I can give labels to my plot or not. I can actually be really specific where I want text added to my plot. So this is just to give you an example where it's done. Again, I'm not going to be testing you on adding text like this. And I'm going to do the axes. So let's see the result of all of this. You can plot without all of these details first and then add them one by one. So you can see slide that alpha transparency, my grid has showed up on top of the plot, by the way. If I remove transparency of the plot, let's just do so I'm gonna comment this part, and I'm just gonna do it without green and without transparency. Let's see what happens. So this transparency, now it's blue is my default color, and transparency is slightly different when you do alpha. These are like small details that you can add to your plotting. And it's extremely hard to see on this screen the differences between transparency. Again, just giving you ideas what you can control. This is a way. There are equations that I could type in. This is just giving it, hey, it's a special equation with symbols. And by the way, by dash mu, I will get mu as a signal. And by dash sigma, I'm going to get this one as a signal. And I'm not going to go into this, but just to show you what's possible. And I can be strict about the location where I put this. So it's roughly around 50, which is here, and 0.025, right? So you can put that location anywhere in your XY space, and that's done here. So you can put any text anywhere around, right? You can add any comment you'd like, right? So if I do any comment in that location. And then grid is true, so I have grid, and axis is between 40, 160, 0, and 0.03. Okay? And this PLT show, it's kind of optional, but especially in Jupyter Notebooks, it might need a help to refresh things. And that way you just refresh the plot whenever you make any changes. It's good to do PLT show. Okay? All right. So you can do all kinds of things with this. And if you don't normalize your histogram, so basically divide by number of points, which in this case is 10,000. When you divide by number of points, you get sort of like a normalized probability of something happening. Otherwise, you just get the count. Oh, there was 5,000 of these numbers and 5,000 of those. So then I would have numbers on the side. Okay? You will plot a whole lot of these in your geostats class. All right. So now we're going to move on with the topic. I'm not going to bore you in this class with how to do font sizes. Okay? But this is just a slide that you can refer to if you need to control the size on your plots. Okay? When you need to produce plots, sometimes, especially for PowerPoint presentations, it's very desirable to have large font sizes because it's otherwise hard to read. You don't want your audience to do this trying to read your plots. You want audience to listen to you. Okay? And there are two ways to control the size. Again, I'm not going to go over this. It's not important for this class in itself. Let's review your plotting of 2D plots. So you have your assignment for data to be plotted is to create 100 points, or their x and y coordinates, that are on a circle of radius 1. And I want you to plot that circle in red color with solid line. And I want you to also find how to change that line width to 2 to have a thicker line. Let's go. And then you and I around, and Jeanette, I guess, to help out. So first you actually have to figure out how are you going to create the data. How are you going to create a plot? This is something from your calculus class, I think. So I expect you to solve it the quickest. Aha, don't cheat. No pressure, though. Does it like this? Because we had a darn little. So again, plotting is PLT.plot of x, y. Question is, what is x and y? Is given. What I know about circle is that x squared plus y squared is equal to 1, but that doesn't give me specific x and y to plot, right? You need to figure out how to get specific x and y to plot. Even though you're very familiar with the circle, getting specific x and y to plot is not available through implicit representation called x squared plus y squared is 1. This is your Jupyter. So I ask people to install the concept. Yeah, just the simplest.
Okay.
And then just go to Jupyter.
Okay. So none of the other ones are like Spider.
Well, I introduced Spider. It is useful sometimes. What I like about Jupyter, you can print PDFs of the homework, and it has things.
Yeah.
It's kind of in sections the way you want it in sections, and they can even make it a little pretty for homework with markdown.
Okay.
But that's kind of optional. Making it pretty is optional, but it's still like just sectioning things, you know, 1A, B, C, D kind of helps, as opposed to grabbing things. So So that's why I Jupyter Notebooks. For any larger programming assignment, I would still favor Spider.
Yeah.
If you have multiple files and all that. So have we come up with anything? Anything? Anyone? How did I get my points? All I know is that PLT plot of xy should do something, but I need something to plot. What are x and y's? Anyone? No? I'm going to write it down here. X is r cosine theta, and y is r sine theta. And I told you r is 1, so hey, just sine and cosine of theta, and I need 100 theta points. That little theta. So a lot of times coming up with theta is not as easy as it actually sounds. You have to draw your knowledge from calculus. Did we do this in calculus? One of them. Yeah? Guess what? You gotta use it. Okay, alright. So let's give us theta. Which function do I want to use? Between 0 and 2 times, and give me 100, please. Yes? And then my x is simply cosine of theta, and not just cosine, but np cosine. And y is sine. Let's see if it's going to remember that I need to import NP and matplotlib. I think it should. There we go. I got some egg. It's an egg. But I wanted it, what did I say? I wanted it in red, I believe. No, what else did I do? Circle. I just said a circle. Red color, solid line. Okay. And I wanted a thicker line. That actually, I'm just going to tell you. I'm not going to wait for you to find out. Line width equals to 2. Settles that part. And I want red solid line. And I can actually tell axes, please make equal axes. I think this should be it. And then I actually have a proportional circle, not an egg. So if you put plt.axis equal, this is now dressing it up. Then it's gonna, instead of stretching axis the way it pleases, it's gonna actually make sure that x and y are proportional to each other. Okay. I could also borrow this PLT grid through and get a grid as well. Again, just for kicks. Yes? So key problem here wasn't Python. You knew PLT.plot of x, y. He was getting the data x and y. Yes? So let's actually now move, in terms of problems with getting data, to 3D plotting. Okay. Let's say that I want to plot a surface in 3D. Okay. So here's my paper. Let's say that this paper is actually shaped like this. Okay. And I want to plot that surface. What do I do? This surface is now in space. Okay. And in order to plot in space, I need x, y, and z axis. So I need x, y, and z data. Better yet, I actually need, so whenever we are looking at something in 3D, there's actually a projection we're looking at. Okay. So we need to figure out, or computer needs to figure out how to produce a projection that we're looking at on the screen. Screen is two-dimensional, right? So there has to be, I'm hinting, a special set of commands that are equipped with, even when I have the data that I'm plotting, to figuring out how to do a certain view of it and position it in space and position the viewer in space and then figure out the projection. Anybody here plays video games? So you can imagine what task that is in a video game. You're the driver, and you're walking around, and you want the surroundings to look real. And the computer has the space description, but it has to figure out where are you as a viewer, and where are you looking, right? And that's what joysticks are my childhood. Whatever it is, you were controlling this video game with, okay? So that's the whole, sort of like in gaming, that's the whole hardship. It's like, where's the viewer in this virtual reality? I have a description of my virtual rooms, booths, whatever it is, right? But where is the viewer so that viewer feels like it's looking and everything is changing as you're looking? So we need to have a separate module for 3D plotting. 3D plots are much more involved. But first I'm going to describe how do I actually create the data. So if I had a surface like this, I can't plot the entire surface. We can't ever plot everything in continuous space. We don't have infinite number of points. So I have to figure out a selection of points to plot. So first thing that I'm going to give myself is a selection of x and y coordinates. Okay? And I put space my x's and space my y's in an equal grid. And then for every x on that grid, and for every y on that grid, and for every combination of x and y, I have to figure out how to compute my z height on this plot, right? Which could be a function of x and y. So once we have x and y's, it's actually easy because we can compute the function of x and y, especially if I have, it's a sine of x plus y or something of that sort. We can figure that out. But the biggest part is actually figure out my grid. Okay? And I need a matrix for my grid. It's a matrix of points, right? X and y. Then I need to figure out my z's for. So let me just first explain it I explained it in part, but I'm going to formalize it now. So in a plot like this, okay, I'm showing you actually a grid over this surface, right? And every point intersection of these lines on this grid is this point that has x and y and a z, okay? And here I have x, y, and z, x, y, and z, x, y, and z, and I need all of those x, y's, and z's in an ordered manner. So this is the data I'm going to give to computer. For all of those little plates that you see in different colors, computer will fit a straight plate in these four neighboring points. So as long as I give it points in order, okay, it's going to figure, for all of the neighbors, it's going to give it a little straight plate, and that's going to give me this idea of a surface, right? And if those ports are really close, that surface will look really smooth. But it's really discretized, right? I have these points and little platelets in between them. That's how we actually represent surfaces on a computer. So let's figure out how to get those points. There's quite a bit of help. So again, I'm going to look at this plane here, and I'm going to look at this -2, -2, and I'm going to point in a mouse so you have it in a video. So there's -2, -2. Its x coordinate is -2, its y coordinate is -2. When I move over here, I have x coordinate is what? -1, and what is my y coordinate? -2. So actually for all of these lines, this entire line right here, and I can't draw a straight line ever, not with my hand, not with my mouse, okay? This entire line is all of the y coordinates at -2. And my x coordinates go -2, -1, 0, 1, 2. Is everybody agreeing with me? Then I move over to the next line. This line has all of the y's -1. And x's are repeated, -2, -1, 0, 1, 2. And then I move over to another line. And all of the y's are 0, 0, 0, 0, 0. X x's are minus 2, minus 1, 0, 1, 2. Everybody sees a pattern? You could technically tell computer all of those x's and y's in a matrix, right? So if I had a matrix, I would have matrix of y's, and each row would be repeated minus 2's, minus 1's, 0's, 1's, and 2's. Right? And each x, it would have this repeated entire vector that is like repeated throughout. Yes? So that's how we're gonna put together the data. Huh? I'm gonna have a matrix of my x coordinates, a matrix of my y coordinates, and at the matching point, like row and column, that describes one of the points in space. And I'm gonna then compute what is a function of those x and y in that particular spot. Okay? And I'm gonna place those results into a matrix Z. And then I'm gonna plot x, y, and z. Yes? But x, y, and z are matrices. So again, for all of the points, I'm gonna put xc. So I have functions. Okay? First step is to create these x and y's that have these nice grids within. Right? And I have a great function called mesh grid that does precisely that. So all I'm gonna give it desired x's, like a vector of x's, and desired y's. And in this previous case, the vector would be minus 2, minus 1, 0, 1, and 2 for both x and y. Okay? And then this mesh grid will give me two matrices that basically repeat these in columns and rows and give me points to work with. And then I compute my function the way I want to compute it. So let's do, and we need this module plot, mplot3d. And we're going to get to that, but I'm just going to tell you that then once you have x, y, z, there's a multiple number of functions the way you can plot the data. So you can plot the surface, wireframe, and contour. And I'm just going to flash the results, and we're going to then get on to doing them. So this would be a surface plot. We're going to get to producing this one. This would be a wireframe plot, contour plot in 3 dimensions, and a projected set of contours in x, y. If you ever go hiking, you get a contour plot, right? And if you want a strenuous hike, then you go to spots where these contours are very dense, because then the values change quickly over a short distance, right? Or if you want a really easy hike, then you follow one contour and you're never going up or down. You're always in the same height. Okay, so contours are basically heights, or the points where the function has the same height. Yes? So let's get to plotting this. This is our motivation, and we're gonna probably just do first plot, but let's get doing anyway. Do it anyway. So you do have lecture 2.5 plots in 3D shared with you. I'm actually just gonna work in a new one in order to just type things again. So first, let's just give ourselves very simple. So let's say that I wanted to go from 0, I wanted number 0, 1, 2, right? I could do something like give me 3 points in this, right? Whoops. Oh, I didn't import NumPy as NP as I created this new one. So if I print x, that's giving me 0, 1, and 2, right? And just for very small examples so that we can visualize everything, let's just do 2 points, 0 and 1. So these are my XY arrays. So let's say that I have this 0, 1, 2, and 0, 1, and I want to create sort of this grid that has x's sampled from 0, 1, and 2, and y's sampled from 0, 1 over a two-dimensional grid. Right? This is where this mesh grid helps out. I'm going to say x and y uppercase. Those are my matrices. I'm going to just say NP mesh grid creates the grid I need from vectors x and y. And I'm going to print those, oops, uppercase, and print y. There we go. So again, my x's are x and y. I'm going to, so my x is 0, 1, 2, 0, 1, 2. Remember how my x's were going repeated? Like the entire vector, I just repeated twice. And in the first row, all of my y's are 0, and all of my y's are 1 in the second row. If you wanted precisely what I had on slide, I could get 5 points between these. Okay? It's just a little more busy. But this was my first row of x's, and all of the y's are minus 2. And then second row of x's, and all of the y's are minus 1. Okay? So those are matrices that correspond precisely to this situation, these points, this grid below. Yes? X's separately, y's separately. Yeah? And mesh grid just helps me create those. Cool. So now actually let's go to an example. What we're going to plot is a function z. Well, next time we're going to plot a function z that is 2 minus x squared minus y squared. So my z of xy is 2 minus x squared minus y squared, and I'll be able to create the data and plot it. Okay, in 3 different versions.
Is there a homework?
There will be homework. It's not assigned today.
You don't need to sign it.
Yeah.